Okay, so welcome to all of you. Now we will see how to find the roots of equation by using Newton-Raphson method. Okay, so now this is the explanation of the Newton-Raphson method. So what we will discuss the Newton-Raphson method to obtain the root of the equation f of x is equal to 0. So what we will do first, let x naught be an approximate root of the, this is x naught is the approximate root of the equation f of x is equal to 0, and x1 is equal to x naught plus h. This is the error in x naught because x naught is the approximate root. H will be the error there. Okay, so x1 is equal to x naught plus h with the correct root of the equation f of x is equal to. This is the correct root means what? It satisfies the equation. So therefore f of x1 is equal to 0. So x1 is what? X naught plus h. So x naught plus h. So by Taylor's, so we'll write here by Taylor's theorem. By Taylor's theorem, f of x naught plus h is what? X naught plus h, f of a prime x naught plus h square upon 2 factorial f double prime x naught and so on is equal to 0. This is the Taylor's theorem. Okay, so we have applied here Taylor's theorem. Okay, so last year we have seen the Taylor's theorem. Okay, so that we have applied here. So what we will do, we will neglect the second derivative and higher derivative. Okay, so that what we get, f of x naught plus h, x naught plus h f prime x naught, and that is equal to 0. So your h is the error is nothing but what? Minus x naught upon f prime x naught. So then x1 is equal to, now this is, you are neglecting this term now. Again this h will be the error. This is not a, this is the approximate error also. Okay, so value of h is also not correct. So that means what here? Just we got this h. So x naught is what? X naught plus h. So this is the value of h. So x naught is x1 is equal to x naught plus x naught upon f prime x naught is a better solution. This is the better. This, it is also approximate. This is not an exact solution. It will be the better approximation than approximate root than x naught. Okay. So now what do we do? Then x1. Then the next approximate root is the next approximate root is x2 is equal to x1 minus x1 upon f prime x1 and so on. So this is what? XR is equal to XR minus, we'll write here XR plus 1 then. XR minus XR upon f prime XR, right? So here what? This is very easy. You need only the initial root, one single root, right? You want only the initial root. With the help of this formula, you can obtain the roots of the equation. Here we are only finding what? Here we are finding only f prime. So here we are finding only the derivative. So something is wrong here. This is not x naught actually. This is f of x naught. This is what? F of x naught. This is not x naught actually. This is f of x naught. Okay. So this is f of x naught. Okay. So now this is what? F of x1, and then this is what? F of xr. Now here only we have the, we want the values of the f of x1 and its derivative also. Okay. So now here we are not testing that whether your function is positive, value is positive, negative, previous one, that we are not doing here. This is very simplest method. Just we have the formula, iterative formula we have. Just we are applying this iterative formula to find the approximate root of this equation. So if the question is asked like this, what? Correct up to 3 decimal places. Just see 2 consecutive iterations so that what? They are correct up to 3 decimal places. So we have the already straightforward formula for this one. Remember this formula for Newton-Raphson method is what? XR plus 1 is equal to XR minus f of XR upon f prime XR. Very simple formula for Newton-Raphson method. Always use this formula for Newton-Raphson method. This is very simple method to find the root of the equation. Okay. So now we'll see the problem. We'll solve the problem. We'll solve the problem so that you will understand the method. Find a real root correct to 3 decimal places, 3 decimal places of the equation x raised to sine 2 minus 4 is equal to 0 near x is equal to 4.5 using Newton-Raphson method. Okay, solution. Given that f of x is equal to x raised to sine 2 minus 4 is equal to 0. So f of x is x raised to sine 2 minus 0 and x naught is equal to 4.5. It is the initial root is provided to you. Okay. So for Newton-Raphson method we need the initial root. Okay. Anything. Now if your root lies between 2 and 3, right? If your root lies between 2 and 3, if you know this root lies between 2 and 3, you may start from 2.2. You may start from 2.5. But it is better to start from 2.5 because what here? So this is 2 and this is 3. If your root is near to this and if you are starting from 2.2, then it is very you have to do more iteration to reach this point. So it is better to take this 2.5. So here what? The root may be here or may be here then. Okay, you will reach there. Okay, within less iteration now. Okay, so now here what, if you are assuming that 2.2, then you have to do the more iteration to avoid that. So take the middle one now, right? So if the initial root is not given, then you have to try for this one. You have to find a and b such way that f of a into f of b is less than 0. Only for the initial stage. To find the initial root, you have to do this one. Once we get a and b, then this a and b we are not using this a and b anywhere. Okay, so we are taking any value lies between a and b, that will be your initial root, and then you can start for this one. So you can reach your desired root. Okay, now why? So before that we will find, so we know that you need to Raphson method, so you need the value of f of x naught and this one. So we will find f of x naught, this is what, f of 4.5, this is what, 4.5 raised to sine 2 minus 4. We are not considering this is positive or negative, this one. So we find f dash x also. Okay, so here f dash x is equal to sine of 2 x raised to sine 2 minus 1 minus 4. Now here your calculator should be in the radian method. Okay, so your calculator is in degree method, then you will get the wrong answers. Okay, so your calculator should be in the degree method, in the radian method. Okay, so in derivative there is no minus 4 because derivative of minus 4 is 0. So for derivative it is only this. Okay, so now I will write the value of this one because I don't have the scientific calculator. Just I have solved this as before. So just I will write this value here. Okay, and f prime x naught and f prime x naught. Just I write x naught. No need to write the f of 4 point f dash 4.5 and so on. Okay, so this is what, sine of 2 x raised to x means what, your x naught is what, 4.5 sine 2 minus 1. Okay, so how to write this? This is what, sine 2, write in bracket, write this in bracket. So 4.5, also write raised to, this is raised to, write in bracket sine 2 minus 1, complete the bracket, complete this bracket. Okay, type like this, sine 2, just write the bracket, also write in bracket 4.5 raised to, write this in bracket and bracket complete, and just press this equal to. So whatever you will get the answer on the screen, just write this answer on the screen. So answer on the screen, it will be 0.79 0.798. Okay, so this will be, you have to find the value of function and its derivative for this. Okay, the next approximate, okay, by Newton-Raphson method. Okay, so we'll say only here another for next one we are not saying anything now. By Newton-Raphson method, the next approximate root is x1 is equal to x naught minus f of x naught upon f prime x naught. So this is equal to, what is your x naught is 4.5 minus, what is your f of x naught is minus 0.07387 upon 0.7918. Okay, use the scientific calculator. This minus will become plus. Okay, just type this in 4.5 plus this divided by this equal to, so you get the value of this one. Okay, no need to find separate the this ratio now here. Okay, directly write the value because scientific calculator is allowed to you. So directly write the value of this one is what, 4.5931. This will be your x1 now. Okay, so what we'll do, we'll find f of x1, and f prime x1 now. We'll find this f of x1. Once we get x1, just find f of x1 and f prime x1. So f prime x1, that is what, f prime x1 is what, 4.5931 raised to sine 2 minus 4, and this is what, so sine 2, 4.5931 sine 2 minus 1. So you have to find these two values. Okay, so what I got this value, okay, so I got these values as minus 0.123468, and I got this value is 0.7918. Okay, I don't need the previous one. What this, which one is less than 0, which one is the greater than 0. Okay, so just I am writing here x1, your x0 is what, x0 is 4.5, your x1, what you got, x1 4.5931. okay, so now we'll find x2 now. So x2 is equal to x1 minus f of x1 upon f prime x1. Very simple formula for Newton-Raphson method. Okay, so your x1 is 4.5931 minus 0.0005668, whatever this value, just write this. So 0.7918, and this is equal to, just what, this is plus sign here, just type this in plus this upon this that means divided by this. So whatever the value you get, that is 4.5932. So see, up to 3 decimal places we get the value. So what is our question? So our question is what? Correct up to 3 decimal places. So 593, we get a correct up to 3 decimal places. Okay, so we write this is what the desired root is. We will stop here. The desired root is x2 is equal to 4.5932. Okay, so we stop here. No need to find a further root. Okay, so if it is correct up to 4 decimal places, question is like this, then what we have to do the iteration. Now your question is what, correct to 3 decimal places, so we'll stop here. Okay, so we'll stop the iteration now here. No need to find a further root now here. So if you do more iteration, we get the you get the correct root, actually near about the root of this one, so that the error will be less now. Okay, so we'll get a better approximation. If you do more iteration, you get a better approximate root. Okay, so now we'll do find a real root. Find a real root a real root correct to 3 decimal places correct to 3 decimal places of the equation x sin x plus cos x is equal to 0 near pi, near x is equal to pi, using Newton-Raphson method. Okay, solution. Given that f of x is equal to x sin x plus cos x is equal to 0. So we are applying the Newton-Raphson method. That means you need the derivative. So just we find the derivative now. So here you have to apply the product rule. X cos x plus sin x minus sin x. Okay. So derivative of cos x is minus sin x. So this will be equal to x cos x. Okay. Now this f dash is very simple now here. So now your x is what? Pi. So you may write the approximate value of pi, or there is a facility in the calculator the value of pi here. So only one time you have to find the value of this one pi, right? So for the next one you don't need the pi now here. Okay. So there is a facility of pi is there in the calculator. If it is not there, then you have to write the value of this pi here. Okay. So now your x naught is pi here. So we'll find f of x naught now. F of x naught. What is f of x naught then? Pi. Sin pi is 0 now here. Cos pi is minus 1. So this will be minus 1. Because sin pi is 0. Okay. So very nice now here. So now f prime x naught is what here? So cos pi is minus 1. So this will be the minus pi. And whether we need the value of pi. So we write the value of pi as, we know the value of this one, minus 3.1416. Up to 4 decimal places, just write this one. Okay? Whatever the value you get in the calculator, just up to the 4 decimal places, write this. So take care of the last, that is 4 digits, right? So if it is 5, that means if your fifth decimal place is what? 5 or greater than 5, just increase the previous one. That means what here? It will be what? If it is 5, then it will be 7 now here. Okay. So now the value of the pi is what? 3.1416. So that means what? Actually, you know this is what? 3.142 is the up to correct to the 3 decimal places. It is, we are taking this as 2 now here. But now here what? We will take the up to 4 digits. So it will be 6 now. So your 4th decimal place is with the 6 now. Okay. So we'll do this one. Okay. Now we'll find by Newton-Raphson method. By Newton-Raphson method. The next approximate root is the next approximate root is x1 is equal to, very simple formula, for this one. Okay. So f dash of, so this will be f dash of x naught. Okay. So what is your x naught? It's pi. So we write here instead of pi, we will write 3 point. Okay. Instead of this pi, we will write this is what? 3.1416 minus, what is your f of x naught? Is minus 1. So this will minus 1 upon this. So upon again minus 3.1416. So minus become plus now here. So you have to take the, this is what this, but this is what minus. No, this is what, both the numerators are, denominators are negative. So they will be as it is. So it will be this, minus will be as it is. So type this like this what? 3.146 minus. So 1 divided by, okay. So this, and place this equal to, so you get the value is 2.8233. Okay. So your x naught is what? 3.1416. Your x1 is what? 2.8233. 2.8. So we have to find the value correct to the 3 decimal places. Okay. So that means what your first 3 decimal should be the equal. Okay. So now we'll find f of x1 and f prime x1. So we don't need this x cos x. Okay. So this is your f prime x. Okay. So now f of x1 now. F of x1 is what? So 2.8233. Just write this sine of, this is not cos of, this is sine of bracket 2.8233 plus cos of 2.8233. Okay. So this value is just do this one 2.8 sine bracket this plus cos bracket this. Okay. And press equal to. So if you press equal to, then the value will be minus 0.06623. This will be the value. Okay. And f prime x1 will be what? So 2.8233 cos of 2.8233. This is equal to. Just type this as a calculator. You will get the value. This is minus 2.6815. Check whether you got this value or not. You get the value of by using the scientific calculator. Okay. If you don't get this value, then you are doing mistake. So that means what? Your command is wrong. That means what? Your calculator should be in the radian measure. Okay. If it is not in the radian measure, you will not get will not get these values. Okay. So take care of that one. So your next approximate is what then? X2. X2 is what then? X1 minus f of x1 upon f prime x1. Very simple formula. This is what? X1. What is your x1? Is 2.8233 minus 0.66623 upon minus 2.6815. So this will be, this minus become plus. So middle one will be minus as it is now. Okay. So what you have to do? This minus, you have to write, don't type on the calculator is minus. So minus this divided by this and just press equal to, you will get the value 2.7986. So your A will be 2.7986. Okay. Now you have to find f of x2 then. You have to find f of x2. So f of x2 is equal to, so 2.7986 sine of 2.7986 plus cos of 2.7986, and this value will be minus 0.0056, and f prime x2 is 2.7986 into cos of 2.7986, and this value is minus 2.6356. Okay. So now you get f of x2 and f prime x2. So we'll find x3 now. x3 will what? x2 minus f of x2 upon f prime x2. Okay. So we write x2 now. What is your x2? Is 2.7986 minus 0.0056 upon minus 2.6356, and what we get? This will be 2.7984. Now see, up to 3 digit. Your question is up to 3 digit. Okay. So now we'll stop here. So therefore, x3 is equal to 2.7984 is the desired root. Okay. So because question is up to 3 decimal places, so 798 you get this. So you have to stop. If it is up to 4 decimal places, then you have to do one more iteration. You have to do one more iteration. Okay, one more or two more. So we don't have the guarantee of that one. So you should have to do more iterations then. Okay, if it is up to 4 digits. So that 4 decimal, this 4 decimal places should be equal. Okay. Okay. So I hope that you understand this one. How to find the root by using Newton-Raphson method. Newton-Raphson method. Okay, so now here we will see find a real root. Find a real root correct to 4 decimal. Now here what? 4 decimal places of the equation x e raised to x is equal to cos x using Newton-Raphson method. Okay, solution. So f of x is here x e raised to x minus cos x. Okay, so now scientific calculator is allowed to you. So we'll find f of 0 now. So what is f of 0? F of 0 is minus cos 0. So cos to 0 is 1. So this is what? Minus 1. Okay, so this is negative. So now we'll find f of 1 now. F of 1. Because what here? Initial root is not given. So therefore what we have to do? You have to find a and b such way that f of a into f of b negative. And we are taking any value lies between that 2 point a and b. Okay, so that we'll see. What is all this? Okay, so what is the f of 1 now? F of 1 is e minus 1. So value of e is something value of e is something. Okay, so this is not 1. This is cos of 1. E minus cos of 1. So cos of 1 value will be what? 2 point. You have to do with the help of scientific calculator only you can find. This value is 2.179. Okay, so that means what your root lies. So therefore this is what less than 0 and this is what greater than 0. Therefore root lies in 0 1. Root lies in 0 1. So you can take any value as you wish. Okay, so you may start from x. X is equal to 0.1 or 0.2 or 0.3 or 0.4 or whatever this. Any value, or you may start from 0.9 also. Okay, so but it is better to take the middle value because what? If your root is what here 0 and here 1, if your root is near to here and if you are starting from 0.1, then you have to do the more iteration. Okay, so therefore we'll take the middle value 0.5 so that we will reach to here or here. Okay, so what we need to do the we need to do the less number of iteration now, so that we will take the middle value. Okay, so we take the middle value. So let x naught is equal to 0.5 be the initial root. You can start any point. Okay, so but you have to do the number of iterations, or this may happen that so you if you are start from 0.9. Okay, so your desired root is what? 0.9235. Then easily with what? So less number of iteration you will reach here. Okay, so but we don't have the guarantee of this one. So which one is your root is now? Okay, so here we get only the position of the root. Where is your root lies in? That we get here. Okay, so now you got x naught. So what you have to you need to find f prime x also, because you know that in the Newton-Raphson method we need the derivative. So find the derivative of this one. So this is what? X e raised to x plus e raised to x plus sin x. Okay, so this is your derivative here. Okay, So now we have to find f of 0.5. F of 0.5 is what? 0.5 e raised to 0.5 minus cos 0.5 is equal to, and you need the f prime 0.5. So this is 0.5 e raised to 0.5 plus e raised to 0.5 plus sine 0.5 plus sine 0.5. So whatever the value we get, so actually what we get the value of this one, this will be the minus 0.0532 and this is 2.9525. So we are not checking with this value positive or negative, whatever we get, we are accepting that one. Okay. So now by Newton-Raphson method, the next approximate root is x1 is equal to what? X0 minus f of x0 upon f prime x0. Okay. So we write x0. What is your x0 is 0.5. So this is 0.5 minus, just we got f of x0. This is your f of x0. This is your f of x0 and this is your f of f prime x0. Okay. So what you get? F of x0 minus 0.0532 upon 2.9525. Okay. Use the scientific calculator. This become plus now. Minus this become plus. Just type 0.5 plus this figure divided by this figure and press the equal to. You will get the value is what? 0.5180. Okay. So now your x0 is 0.5. Your x1 is what? 0.5180. Okay. So we have to find the root correct to the 4 decimal places. Okay. So now we will find f of x1. We will find f of x1 and f prime x1. So here what? We don't need the previous value. Only we need the x1 and f prime x1 now here. Okay. So f of x1 is what? So 0.518. So this is no need to write this 0 actually here. So e raised to 0.518. You may write 0 or no, if you don't write this 0 then also okay. So 0.5180. So this is equal to, now f prime x1 is equal to 0.5180 e raised to 80 plus e raised to 80 plus sine of 0.5180. This is equal to, okay. So we get this value is 0.008 and this value is 2.9525. Up to 4 decimal places we are taking this value. Okay. So the next approximate is what? X2 is equal to x1 minus f of x1 upon f prime x1. Okay. Now your x1 is what? What is your x1? Your x1 is 0.5180 minus 0.008 upon 2.9525. So if you do this calculation, you get 0.5178. So your x2 is 0.5178 now. Up to 2 decimal places we get. Up to 2 decimal places we get a correct root. Okay. So now we have to do one iteration. Okay. So up to 4 decimal places we need the correct root. Okay. So your x3 is equal to, you have to find x3 now. For x3 you need f of x2 and f of f prime x2. So f of x2 and f prime x2. So f of x2 is what? 0.5178 e raised to 0.5178 minus cos of 0.5178. 0.5178 e raised to 0.5178 plus e raised to 0.5178 plus sine of 0.5178. So this value we need. Okay, so these values are this is 0.0 and this is what 3.0421. Okay, so now your x2, your x3 will be x2 minus f of x2 upon f prime x2. So this is x2 is what 0.5178 only. Okay, now we get this up to correct code because this f of x2 we get 0 now here, so we get this. Okay, so therefore what x3 x is equal to 0.5178 is the desired root. Okay, so now we have solved number of problems here. 3 problems here we have solved. So I hope that you understand this one. Now we'll solve the next problem. Derive the Newton-Raphson method. Raphson method for finding the value of the value of 1 by n, means reciprocal of the number where n is greater than 0, where n greater than 0. Find the value of 1 by 19. That is reciprocal. You have to find formula. With the help of this formula, you have to find this. 1 by 19 using initial approximation as 0.05. Okay, so you have to do this one. So what here your f of x is what 1 by n. Okay, so you have to find the value of this. Okay, so okay, solution. What you have to do? You have to find the value of 1 upon n. Okay, so let x is equal to 1 upon n. Okay, so therefore x minus 1 by n. So instead of that, we write 1 upon x then. We write 1 upon n. 1 upon x is equal to n. Okay, so this implies that 1 by x minus n is equal to 0. So your equation is what? Therefore f of x is equal to 1 by x minus n, and for this you need the derivative. Okay, so this is minus 1 by x square. Okay, so what is your Newton-Raphson method? You have to find the formula for this. Okay, so now your xn plus 1 is what? Xn minus f of xn upon f prime xn. Okay, now this is what xn, then this will be the xn. Okay, we need the general formula. Okay, so here what? n is equal to 0, 1, 2, 3, 4 dot dot. Okay, so this is the Newton-Raphson formula to find the root of the equation. If you put n is equal to 0, we get x1. If you put n is equal to 1, you get x2. If you put n is equal to 2, you get x3, and so on. Okay, so xn minus f of xn. What is your f of xn? 1 upon xn minus n upon f prime xn is minus 1 upon xn square. 1 upon xn square. Okay, so now what is this? This is nothing but xn. This minus minus become plus. 1 upon xn minus n. Okay, this is the reciprocal, so you have to multiply this xn square. You have to take the reciprocal of 1 upon x square. So just multiply this, what you get then? Multiply this, what you get? xn plus xn plus xn minus n into xn square. So this is what then? Twice xn minus n into xn square. So this is what? Xn plus 1. This is your formula. This is your formula. Okay. Now what you want here? But you want here what? Reciprocal of 1 by 19. Reciprocal of 1 by 19. That means what here? Here capital N is equal to 19. Capital N. So your capital 1 by n. Okay, 1 by n. That means your capital N 19 and your x naught 0.05. Your x naught is 0.05. So you want x1 now. So what is x1? X naught twice x naught. Okay, twice x naught. You are putting n is equal to 0 here. Minus 19 xn. Xn means what? X naught square. X naught square. Okay, this is your formula to find the first approximate root. Okay, so this is what then? 2 into 0.05 minus 19 0.05 square. Okay, so you get this value as. So now this is what x1. You have to find the correct up to at least 3 or 4 decimal places. Okay, so this is the general formula. So what we will find the value of this one correct up to 3 decimal places. Okay, we'll do for 3. So it is not given. So just what 1 upon 19 is given. Just what happened. So we'll find it up to the 3 decimal places. So your x1 is what? Whatever the x1 we got here 0.0525. Okay, this will be x1. Now see now this what your x2. Just will write the general formula x2. So what here? Replace n is equal to 1 now here. Twice x1. Yeah, your n is 19 now. Capital N is 19. So minus 19 x1 square. So your x1 is what? Just will put this value. So 2 times. This is what? 2 times. So 0.0525 minus 19 0.0525 bracket square. How to type this? Just write this as it is in bracket. 2 bracket this minus 19 bracket this square. Just type on the calculator. Okay, like this. So and just write equal to. You will get the value of this one. On scientific calculator you have to do this one. This will be 0.0526 now. Now x3 will be. So twice x2 minus 19 x2 square. Your x2 is what? 2 0.0526 minus 19 0.0526 square. What I have to do? Just write type as it 2 bracket this minus 19 this bracket and the rest to 2. Okay, and just press equal to. You will get a value. So this is what? 0.0526. Okay, so you get this one what? Actually we get a correct up to the 4 decimal places actually. Okay, so therefore x is equal to 0.0526 is the desired root. Okay, so we get this one. So here what? We need the function now. For Newton-Raphson method, we need the function. Okay, so now see with the next problem. Find the value of root of 142, whatever this cube root, whatever this 142 by Newton-Raphson method. Correct to 4 decimal places. 4 decimal places. Correct to 4 decimal places. Okay, so now here what the initial value is not given to you. So for that, okay, the solution, let x is equal to 142. We'll write x square is equal to 142. If it is cube root, write x cube is equal to. Okay, so this implies that x square minus 142. We get f of x. Okay, you get f of x. So f of x is what? X square minus 142. So if they ask like this, find the approximate value of this is what? Suppose this is 9 to the power 7 by 5. Suppose what we will do? We will write x is equal to this. We will write x to the power 5 is equal to what? So 9 to the power 7 now. Okay. So now this is what, then x to the power 5 is equal minus 9 to the power 7. Keep 9 to the power 7 as it is. No problem for this one. Okay. So now f of x is what? X to the power 5 minus 9 to the power 7, like this. If it is 1 by 5, no problem for this one. If it is 1 by 5, that means what? The fifth root of 1 by 9. This is what? Fifth root of 9. Fifth root of 9. Then this will what? This will be not there then. Right? X raised to 5 is equal to 9. So x raised to 5 minus 9 will be your function. Okay. So now you want here f dash x also. F dash x. This is what? Twice x. F dash x is twice x. Now here you need to find the approximate row here. So now here what? You know that 121 is less than 142 is less than 144. We know that. Okay. So therefore what? Root of, so this is the 11 is less than 142 is less than, so this is what? 12. You can use that. Or it is better to what? Just find the root of 142 and take the nearest root of this one. Don't take the exact root. You take the any root now. So what I will do? I will take the, so your what? Root lies in, so root lies in 11, 12. Okay. So by these calculations, I got this. So where is your root? Okay. Where is your root? Your root is in 11 and 12, in between 11 and 12. So whatever this, we will start from the take x naught is equal to between this. So this will be, I will take, this is 11.5. You may take 11.7 or 11.7 or 11.8, anything now here. Okay. You may take this 11.7 also. So that is in your hand. So see, this is what 142 is very close to 144, right? So you can take 11.7 also. You can take 11.9 also here. What? So because what, your 142 and 144 is very close to each other. So that means what? Here what? This is your choice now. So if you take 11.7, you will easily reach to the your desired root now here. Okay. So I will take x naught is equal to 11.5. Right. So I am not assuming that. So what, 142 is very near to 142. So what is our rule is what? You have to take the between 12. Okay. So mid of that one, middle point of this one. So I have taken this as 11.5 now. Okay. So now, so I will apply by Newton-Raphson method. By Newton-Raphson method. The next approximate root is x1 is equal to x naught minus f of x naught upon f prime x naught. So before that, actually you need to find f of x naught. So what is f of x naught? So this is what initial root is 11.5 square minus 142. So this is equal to minus 9.75 minus 90.72, and f prime x naught is twice of that one. Easily you can find. This is what 23. Okay. So because what, 11.5, you have to take the double of that one. That will be what, 23. Okay. So we'll put the value here now. What is your x naught? Is 11.5 minus what is your f of? So this is what, minus 9.75 upon 23. So easily you can find the value of this one with the help of the pocket calculator also. So it will be 11.9239. Okay. Once we get x1, you have to find f of x1. You have to find f of x1 and f prime x naught. F prime x naught. So this will be what then? So this is what? So 11.9239 square minus 142, and this is what? 2 times 11.9239. This is equal to. So I got this value as 0.1797, and this value as 23.8478. Okay, now we'll find the next approximate root. So that is what? Then x2. So x1 minus f of x1 upon f prime x1. Very simple formula for Newton-Raphson method we are applying here. So your x1 is what? 11 point. Just write the value of this one, so that easily you can find the values of this one. Just put the x1 is what? F of x1 is what? F prime x1 is what? So you have to put this value. Okay. So minus 0.1797 upon 23.8478. You got this value as 11.9164. Okay. Now your x0 is what? 11.5. Your x1 is what? 11.9239, and your x2 you got 11.9164. Okay. So again, this is not this is equal up to 1 decimal places. You need the find for next iteration now. So we have to find f of x2, and we have to find f prime x2 then. What is f of x2? F of x2 is what? So this is what? 11.9164 square minus 142. We have to find this value, and then 2 times 11.9164. You have to find this value. Okay. So I got this value as now I got this value as 0 now, and I got this value as very close to 0. I got this value. Okay. 23.8328. So you got x2, you got x3 now. So x3 is equal to x2 minus f of x2 upon f prime x2. So what is your x2? Your x2 is 11.9164 minus 0 upon 23.8328. Just write this value. Now no need to use the calculator now, because your numerator is 0, then that term is 0 now. So this will what? 11.9164. Now see, we get a correct up to 4 decimal places. So this will be the desired. Therefore, x is equal to 11.9164 is the desired root. Okay. Now this is the complete solution of your problem. Okay. I hope that you understand this one. Okay. So you have to do the more problems. You have to, if A and B are not given, then you have to find this A and B now. Okay. So I hope that you can understand this one. Okay. So now we will stop here.